Okay, good evening. Welcome to
Math number 653.
FamilyMath653. So we're going to talk about the same problem we were talking about yesterday that your brother was doing. So he was rolling 3 10-sided dice.
Yep.
And he was seeing what number he got when you added the rolls together. And this is what Mathematica told us the probabilities were. So the probability of getting a 15 is 73 out of 1,000. Probability of getting a 10 is 9 out of 250. Probability of getting a 26 is 3 out of 200. Okay?
Okay.
And the probability of getting a 16 or 17 down here is 3 out of 40, which is how much out of 1,000?
Wait, is it 16 or 17, right?
Right. Yeah, 16 or 17.
Well, it's 300 out of 4,000. So maybe we could say roughly, like, 75?
Okay.
About?
75 out of 1,000?
Yeah.
Okay. So 75 out of 1,000 for 16 and 17, 73 out of 1,000 for 15 and 18, 69 out of 1,000 for 14 and 19. And the interesting thing is he was trying to figure out which number would get to 40 first, 40 times. Which number would appear 40 times first. And I think he found 15. But what would you guess would appear?
I would have guessed like 16 or 17. I mean, it has the greatest probability of appearing.
Okay. And so 16 or 17 are 75 out of 1,000, 15 and 18 are 73 out of 1,000. So what do you think the difference in probability of getting to 40 first is? You think it's high or low?
It doesn't seem that big of a difference right now, like 73 to 75. But maybe it's not big right now, but maybe 40 multiplied by 40 times, it would be actually pretty big.
Okay. Well, overnight I ran 1 million trials, and they appear here. Can you check is this on screen?
Yeah, that's on screen.
Okay, so 15 and 16 both appeared basically 206,000 times.
Mm.
And then, sorry, 16 and 17. 15 and 18 were about 160,000 times.
Wow, so there is a big difference there.
Actually 161,000 times. And then 14 and 19 were 93,000 times. And you hardly ever saw 12.
And
11,
on from that, there's like
10,
nothing.
in fact, 10 only appeared 3 times. And 23 only appeared 2 times.
Wow.
So my question to you is, why do you think it's such a big difference? So before we found down here, 16 and 17 were 75 out of 1,000 versus 73 out of 1,000 versus 69 out of 1,000 versus 63 out of 1,000 down to 13. So it goes from 75 out of 1,000 down to 63 out of 1,000, which isn't a huge difference, but you see 75, 73, what was the next one down? 69?
Yeah.
Then 63? It falls off real fast. So I'm curious why you think that happens. Like, why do you think it's such a huge difference?
Well, I think that just because there's more ways to do it with, like, 16 and 17 there are with, like, 3. There's no more ways to make 16 and 17 with 3 numbers from 1 to 10.
Mm-hmm.
I mean, even if there's just one more way to make a number, like maybe 16 and 15, maybe there's one more way to make 16 than 15.
Mm-hmm.
Multiply that by 1 million, that's going to be a pretty big difference.
Okay. Well, we're not quite multiplying. We're every time we do a trial, we see which number we got. And then when we do 1 million trials, we see 16 and, we see which number appeared 40 times first.
Yeah.
And we see it's roughly 1/5 of the time each. It's 16 and 17. And then it falls off pretty quickly away from that. But it falls off much faster than the probability of each individual number appearing. And that's what I was trying to see if you had a thought for why that happens.
I think just because if there's more ways to make a number, and if you're doing it for this large number that of trials, then it'll make a difference. Like, well, it's hard to think of an example, but if you, one more way to make a number would make a pretty big difference over the space of 1 million trials.
Okay. Why do you think, for example, you hardly ever see 10 being the first number to appear 40 times, when the difference is, let's see, it's 36 out of 1,000 versus 75 out of 1,000, so call it half.
Yeah.
Right? So a 10 appears about half as often as 16, but almost never becomes the first number to appear 40 times.
Well, maybe just because of that is the half, and then over 1 million trials like this. And it has to do with like that it's half as much. But I mean, over 1 million trials, you'd be more likely to see a 16 than a 10.
Mm-hmm.
But I think the difference is somehow like scale exponentially as you're doing bigger and bigger trial numbers.
Okay. All right. Well, it's interesting. I was just curious what you might think about this, because it's a little surprising when you first look at it that the small differences here, like between 16 and 15, goes from 75 to 73 out of 1,000.
Yeah.
So a tiny difference.
And still
leads to,
means a lot.
Yeah, 205,000 versus 160,000.
It's 40.
A huge difference.
40,000.
40,000 out of 200,000, so it's a 20% difference. Even well, a little bit more, but it's fine. It's 20% difference versus a tiny difference. So I want to just show you that and see if you can make any sense out of that. All right, well, good. I'm going to ask your brother the same questions later.